How did everything start from nothing? This question is not just about science. It's a deep philosophical mystery that makes us think about the very nature of existence and how the universe came to be. The idea of creation from nothing challenges what we know about the world. Have you ever wondered how the universe came to be? How everything we see around us, from stars to galaxies to the very air we breathe, emerged from something that seemed like nothing? It's a question that not only fascinates scientists, but touches on deeper ideas about what it means to exist and what nothingness really is. How do we go from nothing to everything? In this documentary, we'll dive into these mind-bending questions, looking at the universe through the lenses of particle physics and cosmology, while scientists use math and experiments to try to find answers. There's one question that stands above all others. What does it even mean for something to come from nothing? How can the laws of physics explain how the universe emerged from a place where there was no space, no time, and no matter at all? Let's start with particle physics, the branch of science that's all about understanding the tiny building blocks that make up everything. If you think about the world we see around us, it's governed by the physics you're probably familiar with, the kind of stuff we experience every day. But when you zoom into the smallest particles, things get really weird, and that's where quantum mechanics comes in. Suddenly, particles don't behave in any way we can predict or understand with our everyday experiences. It's a whole new world, one that doesn't play by the usual rules. At the heart of particle physics is the question, what is everything made of? Scientists study particles like quarks, electrons, and neutrinos, the super tiny things that make up atoms, which then make up matter. These particles are so small that their behavior and properties challenge everything we think we know about space, time, and even reality itself. One of the biggest breakthroughs in particle physics came with the development of the Standard Model. This is a theory that explains the fundamental particles and forces that make up the universe, but it doesn't cover everything. According to the Standard Model, there are four fundamental forces in nature. First, there's the electromagnetic force, which is what powers electricity and magnets. Then, we have the weak nuclear force, responsible for radioactive decay. The strong nuclear force is what holds quarks together inside atoms. And finally, gravity, the mysterious force that we all experience, but which the Standard Model still doesn't fully explain. While the Standard Model has been super successful in explaining how particles behave, it doesn't have answers to everything. For example, it can't explain gravity fully, and it can't account for dark matter or dark energy, the invisible stuff that makes up most of the universe but has never been directly detected. To study these particles, scientists use some of the most advanced technology on the planet. Particle accelerators, like the Large Hadron Collider in Switzerland, speed particles up to nearly the speed of light and smash them together. By studying the aftermath of these collisions, they can see what new particles are created and how they behave. This is how they discovered the Higgs boson, a particle that was theorized to exist but wasn't actually found until 2012. The Higgs boson plays a crucial role in explaining why other particles have mass. It was a huge breakthrough for science. But despite all the discoveries we've made, the big question still lingers. What is the universe really made of? And how did it all come from nothing? Understanding these questions is what drives scientists in their quest for answers. And, interestingly, their work leads to inventions that affect our everyday lives. For example, the World Wide Web was created at CERN, the research facility where the Large Hadron Collider is, all to help scientists share data more easily. So, the next time you think about the universe, remember that it's not just about the stars and galaxies. At its core, it's about the tiny particles that make everything tick, and the profound mysteries about how something as vast as the universe can come from what seems like nothing at all.